All right, we're going to take a look at question 20 from the review sheet that you got today, because it was one of the requests. Let's first mark our givens. I'm given that angle A is congruent to angle E, and I'm given that segment AB is congruent to segment AE. Those ones are a little bit tougher to mark, but it's this segment congruent to this segment. And we are being asked to prove that segment AD is congruent to segment EC. So you might first think that you could prove maybe that this will make it purple triangle is congruent to this purple triangle. But for those two triangles, we have the given angles and the vertical angles, but we don't have any sides. And there really isn't a way to get any sides. So proving those triangles is not an option at this point. So we have to prove the pink and green triangles. And so let's write the plan for that. My plan to prove those triangles congruent is, and it's triangle ABC congruent to triangle EBD. I'm going to do angle side angle. The first pair of angles is angle A congruent to angle E, which is given. Then I'm going to prove side AB congruent to side C, which is given. Then my third angle is right here where they overlap. Remember, with overlapping triangles, we always look for the reflexive property, and we have it here. Angle B is congruent to angle B by the reflexive property. Once we get the pink triangle congruent to the green triangle, we know that all of their corresponding sides are the same. And that is going to help us out because this side right here, DB, is the side of the green triangle. So if we take AB minus DB, we'll be left with AD. That's our goal. And then on the bottom, BE minus CE is going to leave us with this. That tells me that this has to be a subtraction proof. So now let's go through the steps, and I'm going to highlight boxes as I explain them as we go through the proof. So first, I'm going to tackle proving the triangles congruent using angle side angle. So I start with angle E is congruent to angle A, which is given. Then my second given, AB is congruent to BE, is maybe my second side. And then angle B is congruent to angle B, reflexive property. 1, 2, 3. Those are the three pieces of my plan. So I now know that the pink triangle and the green triangle are congruent to each other. So we have ABC. This triangle is congruent to EBD, is what we're showing in that step. Next, I need to steal stuff. I need to steal DB and BC because those are the pieces I need to subtract. And so from the triangles, I'm borrowing that DB is congruent to CB. When I borrow from triangles, it's CP, CTC. Because this is a subtraction proof, we can't have congruence, so I converted it to equal. Our reason is congruent segments are segments with equal measure. Now, I am subtracting those segments from AB and BE up here, which is why over here, I converted that also to equal. Congruent segments are equal in measure. Next, I need to break this up so I can do some subtracting. Before I can break it up, I need to define what these segments are made of. And that's what I've done here. AB is equal to AD plus DB. Those are my pink segments. And EB is equal to EC plus CB. Those are the green segments. And if I take this box and this box, and I substitute them in together, I can conclude that AD plus DB is equal to EC plus CB. Well, right here, we have DB equals CB. And that's what we want to get rid of. So if we take and subtract these equations, we're left with AD equals EC. And the reason is if equals are subtracted from equals, the results are equal. But they didn't ask us to prove them equal, they asked us to prove them congruent, which is why over here we've changed it to AD is congruent to EC. And if you check all the classroom posts from when we did segment and angle proofs, you will find more videos on segment addition and angle addition if you want to watch those. Check them out.